Assalamualaikum. My name is Hakimi. My number matric is DD1400007. And I'm from Dr. Muhammad Zaini bin Yunus class, section 3. And I will be presenting my individual project, that is to calculate the total emission from power supply for electronic product. Okay, I would like to introduce my project. In principle, it assumes all the environment impact of resources use, land use, and emission associated with all the processes required by this product system to fulfill this function, from resources extraction through material product and processes. It use of product during fulfillment of its processing of discard product. An energy consuming section that consists of electricity only power plant and combined heat and power plant whose primary business is to sell electricity and heat to the public. Requirement of life cycling assessment LCA is data on production, use, and disposal of the product, that the material and are made from the energy it required. Besides that, life cycling assessment can be used at an operational level, product improvement, product design and development, as well as for product comparison. Thank you. Okay, for problem statement, this project wants us to write and create a type of C program and a flowchart of program that relates to materials engineering. Okay, we have to design and create a program for electronic product that relates to carbon dioxide emission from power supply of electronic product. And thirdly, to overcome the problem, create a program that relates to carbon dioxide emission of electronic product by using an equation and formula. Okay, for the objective, I have to design a flowchart to solve a problem relates to some engineering problem, to write a C program to solve problem relates to some engineering product, and thirdly, to determine the total life for some electronic product and to find the CO2 emission for power supply for some electronic product. By using basic, and fourthly, by using the basic knowledge of computer programming to solve the problem that are related with engineering. Okay, for methodology, this is the flowchart. First we start, and then we display product electrical power consumption in watt, and then we convert it to kilowatt, which is divided by 1000, and then we display product electronic power consumption in kilowatt, the result of this, and then life of product in 1 year display, and then display the average usage in in hours per day. Okay, and then we calculate the total life product in hours by using this formula, which is AU equals to I, that is life of product in a year, and then times the amount of day in a year, which is 365, and then times the hours average usage hours per day. Then we get the total life of product in hours, and then you can see, and then display C, which is 0.684, and then we calculate the carbon dioxide emission from the power supply by using this formula. C equals to kWh, kilowatt, times total life product times C, which is 0.684, and then we can calculate the amount of carbon dioxide, and then display and end. Okay. For the coding, hashtag include stdio.h, and then include conio.h, and then int main, and then we float kimut, and then we float the amount of C, which is equals to 0.684, and then we float kWh, which is kilowatt, and then we print enter the product electrical power consumption in watt, which is K, and then scan F, percentage F, K, and then the amount kilowatt, we got the result from K, and then we divide it by 1000, and then print F, product electronic power consumption K in watt equals to percent F, and then kWh, which is this one, and then print enter the life of product IP, I put IP in years, and then we scan F, percentage F, I, and then print F, enter the average daily usage MD in hours per day, and then scan F, M, and then we could use the formula U equals to I times 365, the days in year, times M, which is the average daily usage, and then print F, total life of product U IP in hours, which is U, and then T to calculate the total carbon dioxide emission for carbon supply, which is the formula is T equals to kWh times U times C, which is this one, the floating C, and then we got the answer for how much carbon dioxide needed. Then get and then end. Okay, for the result, error, and then enter the product electrical power consumption in watt, which is the average is 200 for a television, and then they converted to kilowatt, divide by 1000, which is 0.2, and then enter the life of product in a year, which is 12, and then enter the average daily usage MD in hours per day, maybe 10, and then the total of product IP in hours is this, and then calculated using the T equals to kWh times U times C small, and then The result is 5991.840332. Okay, for the conclusion, it would seem that the objective of this project are achieved, which is to design a flowchart and write a C program to solve a problem related to engineering material. And then engineering problem, and then the solution program during coding was calculated and determine which is the same calculation method. Secondly, to determine the total life and the total supply for each selected electronic product, life of product in a year, average daily usage, hours per day, and product electronic power consumption, kWh, which is kilowatt, and then all of them are needed to be identified. Other than that, the value of carbon dioxide for electricity power plant is 0.684 kg per kilowatt. In addition, the results are also determined successfully by calculation method in computer programming. By using this formula, the formula of CO2 emission from power supply for product. Okay, thank you.